Let me make a quick introduction. We got Emerson. She's the director of Frontier Technology Lab, and she's an avid investor from autonomous vehicle all the way through space technologies. And we got Marco. He came back the second time, and he's going to talk more about mobility. I'm very excited to have him back. And Ijani, chairman of AGI Foundations and good friend, and he focused on edge AI and low power autonomous systems and sensing. And we got Supriti. She's the CEO of Aviation. She may flying both. So that sounds just very exciting. So all of them touch in different areas. We got whole spectrum. We got investors, we got academia, we got research industry. So, and not just that, we got space, we got land, we got sea, underwater, above the water. So anything ability, this is going to be a very exciting panel. So as we know, revolution AI, and I want to kind of get a viewpoint from all the panelists, right? What are things that are happening now in AI you could have done years back, and what make you most excited about the future of AI in the mobility space specifically? So you want to take that first question?
Yeah, sure thing. It's great to see everyone. Thanks for having me as well. I think I'm probably most excited as an investor just in the founders I'm backing and the companies, especially as they're innovating across multiple domains as it relates to mobility. So for instance, on the aviation side, invested in a company called Shield AI that's doing AI autonomy for aviation, from drones all the way up to fighter jets. They have some really great technology around dogfighting, swarming. I think on the ground transportation side, for instance, which is where I initially made investments, as you pointed out, in autonomous vehicles, seeing companies like Zoox, for instance, be able to build an entire vehicle from the ground up and really take a human-centered design approach to it. And then now seeing their plans to launch a robotaxi service in Vegas later this year and then San Francisco thereafter. Recently just invested in a maritime autonomy startup, so excited about the innovations that are happening there that I'm sure Supriti can talk more about, and then have been looking at space autonomy as well.
Yeah, you have the business and investment angle. You must see from the research to application to way how just entire go-to-market to entire process. You must have the first read of the pulse of the market.
Try to.
So. Yeah, try to. What do you think, Marco? I know you have done quite a bit of you have created some impressive research in the space as well as the mobility, and with your work with NVIDIA and the research with the Stanford, especially Sustainable Mobility Lab. So what are you most excited about in the future of mobility?
Well, of course, one of the topics I'm most excited about is how AI is really pushing the boundaries of autonomy for mobility systems, as also Ernestine has alluded to. Self-driving cars first, but of course, that's not the only mode of mobility. Aviation, of course, there is some delay there. Potentially maritime, there's even more delay there. But definitely, AI is pushing the boundaries in all the different transportation verticals. But another way, so basically by improving the autonomy capabilities that are possible in these systems. But another way that the AI is improving things, and oftentimes is overlooked, and I have to say, particularly in the academic community, is how AI is improving and accelerating development processes. So not just the brain that goes into the car or into the airplane or into the space system, but the maybe bigger brain that is in the cloud that is used as part of the development process. For example, in terms of improving simulation technologies to accelerate validation processes or training processes, developing tools to generate scenarios, again, to help with the training, having AI-based evaluators that allow you to assess whether a given system has some behavioral deficiencies and inform how to retrain the system, for example. So putting everything together, this has the opportunity to definitely accelerate the deployment of autonomous systems and helping with their business proposition. Yeah. As I always say, mobility is a particularly difficult market in the sense that ideas abound, But making profit out of those ideas is very, very hard. And
Right.
through the years, we've been going through a lot of hypes and crashes. Yeah. So jointly, AI techniques not only had the potential to boost performance, but correspondingly also the profitability of some of these ideas.
Yes, just through the more efficient simulation and testing without having wasting all the resources, now it can be done with generative models.
That's
and
right.
you spent a lot of time building the AV foundational models. So what's your outlook on that? And I know you guys announced something very exciting last year. So what can you kind of tell people about the future of it?
Well, first of all, foundation model is a very hyped model these days. So I want to define it a little bit more to make sure that we're all on the same page. For me, a foundation model is a model that has been pre-trained on internet scale knowledge, either videos or language. I mean, these are the two modalities that abound on the internet, typically in a self-supervised fashion. It can be adapted to many different tasks. Such a definition is very broad, so there are many different types of foundation models, like video generation models, vision foundation models. One of the models I'm personally most excited about is reasoning models. So those models that are capable of producing human-like reasoning traces. So in other words, they're capable of breaking a problem step by step and explaining how they're arriving at a solution. And this improves, as we've seen, performance, introspectability, safety, and so on and so forth. So yes, particularly the NVIDIA strategy in system autonomy is very much focused on foundation models across the board. Like, for example, video generation models for simulation purposes, reasoning models for the intelligence that goes into the vehicle, and so on and so forth. I could talk for hours on this topic. So.
I mean, it's all about panel. But I think kind of it's perfect side because now people talk about self-defined vehicle, and it doesn't matter if it's a car or boat. It's actually an air-defined vehicle if you think about it, right? And I think, especially you can probably speak about a lot about that because that's where it started. What can you tell about, especially from like sensing perspective, right? We need low power and all of this kind of trade that what we need in the modern AI-defined vehicle. So maybe weigh in a little bit.
Good afternoon, everyone. I'm Evgeny Gusev from Qualcomm. We are leaders in Edge AI, and Edge AI is all about mobility, obviously. But before we go into the main topic, I would like to acknowledge that I'm very happy to be a minority on this panel with Marco. I think that's very good, and thank you for putting this very well-balanced, very diverse panel together.
Happy to have you.
Yeah, I think we should use this panel as a role model for other models in terms of diversity. Talking about innovations in the AI space, specifically Edge AI space, I kind of covered both sides, from the Qualcomm side and also from the Edge AI Foundation. Edge AI Foundation, if you don't know, that's a global organization, global ecosystem of about 100,000 members and more than 100 companies really driving this ecosystem together. So a lot of innovation happened in this space. But if you were to highlight the most significant ones, definitely silicon capabilities are becoming very, very powerful. I think every year there is a new generation of silicon comes, and it's quite amazing what can be done in silicon today. And talking about mobility, you can think about smartphones. If you attach wheels to the things, I'm exaggerating, but effectively it becomes your mobility platform. Like effectively devices we deploy in cars now, and there was an announcement this week with BMW and Qualcomm developing a Snapdragon Ride Pilot. It's a joint software development based on our silicon. Effectively, the silicon is so powerful today that you can run all these workloads, including ADAS, basically on this platform, modified for autonomous for car in terms of temperature conditions, operation conditions, and so on. But the point I wanted to make is silicon today is very powerful, and if you project in the future, you can run a lot of things on this in a very energy efficient way, and that's what the Qualcomm and the Edge Foundation, Edge AI Foundation drive. How do you make it sustainable from the
Can you
energy?
speak about AI on sensors? And that's actually, we can start to see a lot of use cases. And I met a startup just a few weeks ago at the Car Week, and they actually, now the car like Waymos, they can become sort of, start to use on the consumer vehicle as well. Right. So there's a lot of touch on AI on sensor. What can you speak about that?
Yeah, good question. I think my journey with AI started about like 14 years ago. We started a project at Qualcomm. It was like a crazy project. Can we do machine learning at the image sensor area? Because back then, you have to consume like a lot of power. Image sensor consume a lot of power. AI running on CPU consume a lot of power. And we came up with a solution running all computer vision in, actually I have it here. It's a product we announced in 2017. It's very tiny, like a grain of rice, basically. You can run all AI on this type of silicon, just showing that what is possible if you bring AI to the sensor level. So that's kind of what we call the far edge. Then we have the edge, which is this type of devices. And then we have the near edge, like the edge of the internet. And there, what we've shown recently, you can basically bring cloud-based AI, like LLM type of models, down to the edge, and that becomes very powerful. So edge becomes a very interesting platform for development and for deployment, because you can start from very small models at the edge, time series models, and so on, and you can go all the way to LLMs of 100 billion parameters and so on, and you can still deploy them there. And then you have a lot of applications, vertical applications. You have cars, you have AR, you have boats, you have all kinds of space stations. Yeah.
Marco specializes in building large, powerful models, and you want to go small, and that's for good reason, right? There are different use cases and all much needed, in some way complementary, right?
Absolutely. I think in Qualcomm we look at this as a hybrid AI. It's not like one or the other. It's a continuum of distributed AI at the edge for all the devices, but it's all connected in a hybrid fashion to higher level compute when you need to do it. And the agentic AI is actually its next level of this development. Maybe we'll talk about this too.
So pretty. She's a very impressed scientist. She started as an underwater specialist, robotic swarm, and now she makes flying boat. So tell us more about, and I'm not kidding, it's very impressive. It's hydrofoiling on the water, and I don't think, she's probably the only one in the world does that for, have that kind of stylish aesthetic, but yet practical. So tell us more about your world and how you use of AI innovation.
Sure. Yeah, thanks for having me here. And anytime you talk about flying boats, it sounds so conflicting, flying and boats, right? But it is flying boats. It has wings underwater. So from the physics perspective, it's all electric hydrofoiling boat. So maybe I'll give some context here. So yeah, I run a company called Navier, and the big picture is building the next generation American maritime company, because America is really behind. We're number 11 in the world when it comes to maritime. We don't have any merchant fleets. We really have lost all of them post World War II. And the maritime sector, hasn't had any innovation in a long time. I mean, boats are whatever they were like 100 years ago. Maybe some aesthetics, maybe more engines or something, right? So when you look at it, the thing that I'm really excited about, the state-of-the-art technology, AI, and especially also physical AI, robotics, right? And I'm a roboticist by training, and that's what gets me excited. Is where the tables turn is the reason we did not have more shipbuilding or boat building or any of that, because it's a very labor-intensive process. And what is interesting on the first part is now we will see a lot more manufacturing in the US. So it's basically robot factories building robotic boats or robot cars, right? And that's where America is better. I mean, that's where we have our competitive advantage, and that is what is really exciting. And the second part is that the speed at which now we can deploy this complex autonomous system, in our case, autonomous flying boats essentially, is much more faster if you had done this, tried to do it like 10 years ago, right? As you guys were both saying, like for us, we started our production 2 years ago, started delivering last year, completing first batch of delivery. We get data from all the deployed boats, and we are able to build simulation models. We are able to train them, and with being able to generate more and more synthetic data to build pretty high fidelity model, which means that taking a boat out and like training, same like in a car, it's a lot of effort. It is like you're talking about cost, right? So the ease at which we can now deploy large scale autonomous system, the ease at which we can build them, I think it's a game changer. I mean, it's something that we have never seen before.
Yeah, it's the same kind of AI kind of expedited design process in so many ways. I know you even have a text-to simulation, and when I looked at one of it, I was very impressed by that. I want to touch on sustainability. Is the reason why I handpicked all of you. You have the cross expertise domains in sustainability and mobility. So we don't have a lot of time. In a few sentences, kind of share your insights on, one sentence about what you do, and another just kind of your impact you think, the sustainability can make an impact in the mobility as well as the global futures.
Yeah, I guess I can start. I mean, I think the biggest thing from a sustainability standpoint when you think about autonomous vehicles, for instance, is currently most of our cars sit idle for probably 95% of the time. But if you think about AI and AI applications to ground transportation, if you think beyond just the impact it has on the individual vehicle and making that autonomous, but more broader from a network perspective and how AI can be used to automate traffic, routes, the broader network effects of that, I think that has huge implications on sustainability. Of course, I think there's like a little bit of a, call it like efficiency paradox, where it of course costs a lot of energy and compute to train these models. So thinking about those trade-offs. At the same time, I do think we're in a really interesting time when it relates to energy and sustainability. In some ways, I think AI is indirectly solving our energy crisis just by the amount of capital that all of these big tech companies are now putting into nuclear, small mod reactors. You're seeing Google, Facebook, Amazon. So I think we're in quite interesting times when it comes to future of sustainability.
Yeah, it's a little bit double-edged sword, but we're a lot of innovations are putting that forward too. What's your point of view, Marco?
Well, I mean, transportation is one of the most fundamental infrastructures we have in our society. So reasoning about sustainability is critical. So at Stanford, actually, we just started a new center called Stanford Sustainable Mobility Center, where we look at the topic of sustainability broadly in the context of transportation. Of course, sustainability has many different facets. The four main facets that we are focusing on is the aspect of environmental sustainability in terms of electrification of the powertrain, alternative fuels, for example, for aviation, impact on the energy grid. So what happens if, all of a sudden we have 50% penetration rate of electric vehicles in our society? The result will be that we will have, we will blow transformers and we will have like massive power outages. So how do you reason about those interplays between energy grid and transportation? That's the environmental pillar. Then urban infrastructure. So how do we rethink urban design in anticipating new mobility modes? Safety, of course, if these technologies are not safe, are not going to be sustainable and acceptable from society, by society. And then equitability and financial sustainability. We have already talked a little bit about financial sustainability and how it is hard to do innovation in the mobility space in a way that is ultimately profitable. But equitability is another important aspect. For example, one of the technologies that is being investigated for years in order to improve transportation throughput, so essentially to reduce congestion, is referred to as congestion pricing, so basically tolling. You make some lanes tolled, and so if you are really in a rush, then you pay a fee, and then you go faster to your destination. Okay. Of course, that is disproportionately advantageous for some segments of society. Yeah. So to what extent that is an equitable solution? What else can you do in order to make this solution acceptable for the entire society, maybe with rebating program, refundable scheme, and so on and so forth. Final point is that, interestingly, we talked about AI specifically in the context of autonomy, but each one of these pillars actually stands to benefit from AI. For example, AI agents to optimize battery design, or as Ernestine was alluding to, using AI for better coordination models for multimodal transportation fleets, or AI that makes autonomy safer and so on and so forth.
I think Sabrina also has the same sort of route optimization, navigation optimization, some flavor to your autonomous system. You want to jump in that really quick?
Yeah, I mean,
as well as in the context of sustainability, of course.
Yeah, I'll first touch the sustainability concept because it's pretty important for us. When we started Maritime, the Maritime company, we were looking at like, what does the next generation of, what does it mean to build a next generation vessel, and what are the technology in the stack, right? And it was obvious that when you're thinking of transportation vessels, they are going to be eventually be all electric or like zero emission, not in a single step, but eventually. And then autonomous and scalable, those were the key things, because you can see that that's happening in the land and the air. One of the big problems in maritime adopting electrification was that it just, it just loses range. Like if you build electric boats, I mean, the reason people do not want electric boats is because you sacrifice the range immensely. You're pushing water, so that doesn't work very well. I mean, your battery is super heavy, and now you get like 1/5 of the range. A gas boat is doing 250 miles, and on an electric boat, you're doing 30 miles. So that's where what we started building was the electric hydrofoiling boat, right? And that's became, I mean, our boat is the longest range electric boat in the world. And this is interesting because electric hydrofoiling boat is not like, it's not like, hey, let's do sustainability for the sake of sustainability. It actually unlocks a scalable business model that's not possible with the gas boat. Basically, an electric hydrofoiling boat is 15 times cheaper to operate than a gas boat. And suddenly that unlocks a whole use case for transportation, because you would not take small boat for transportation. What cost you like $10 to go by car, then it would cost you $150 to go on a similar small boat. So this is where sustainability and profitability goes hand in hand, which is very exciting for us.
Yeah. So I want to finish up with I think probably what if few organizations think about sustainability first, because of the nature of being ultra low power, using power operated, rather than to try to rely on cloud computing. So we in 15 seconds, closing for us, the sustainability and AGI.
Yeah, I totally agree with Marco that sustainability needs to be addressed in a holistic way, not just in a piece way. You need to look at the system holistically. One part of the system is energy efficiency of the hardware. That's basically your horsepower, right? And this is happening. The other way is how do you design a system that is efficient there? So you can run a 300 billion parameter model, or you may be able to get this same answer with a 10 billion parameter model, right? You need to be smart how do you use this kind of thing. So it's both how do you design the systems and the mindset, how do you use them in a way that it's efficient, including all the applications like flying boats and so on. And perhaps kind of as a call to action, Stanford, maybe other institutions, they should start teaching design for sustainability. Maybe you already do here, because that's an important kind of...
Interesting, the 5 pillar at the center is called co-design. Yeah. But I didn't talk about it because I wanted to be...
I think it's important for people to start thinking about it from the mindset perspective. It's not like you're using brute force what is available. Like, why are you using this? Maybe you don't need to use this tool, this kind of things.
Right. Well, I mean, I want to thank you all. You guys are, amazing. And I know I don't have time for questions, I promise you, but...
we just have a few minutes to ask the audience a question, but I've got a personal question to ask. It's also related to Arissa. She and I love burning gas. We love burning rubber. Are we going to get eliminated in the future? So,
are you trying to undermine me? We also like boating. We're also boaters
as well. Yeah. But anyway, we use wind power for that. But when it comes to the road, it's a different. Do we have a future?
As long as it is for fun, I mean, we're feeling...
Right. Okay. Anyway, questions from the audience.
Actually, I had a question for Arissa.
What?
I want to as the question that you asked, I want to understand the context behind your question about sensors. What are you seeing, and like, why do you ask that question? And I ask that because I'm having that debate internally as well. Are you seeing a need for new forms of sensors that will feed into the AI system, or are you seeing a need for deriving meaning out of all the sensor data that is already being generated, or was it something else?
Well, I can answer the question, but I think he answered the question a lot better than I do. He's the chairman of the foundation.
Yeah. If I could add to this, John, I think all sensor people, like big company, ST, Bosch, all of them, they're including intelligence to the sensor level now. And the reason for this, fundamentally, you want to digest the data where it is, and then trigger only action when you need to do it, like action cameras and other things. You don't want to run them continuously. If something happens, which is a very low duty cycle, maybe 1%, then you generate actions there. So
I'll add a quick comment on that.
And also privacy, obviously, is a big driver for this. But talking about sustainability, you don't want to burn whatever oil or gas or whatever if you don't need to. I mean, at the sensor, the physical world level, you monitor what happens there, and you trigger only when things need to happen, either in autonomous driving or security or any kind of environments. That's what basically the whole TinyML concept is about.
Essentially, what we're getting to is basically AI everywhere. AI can be very powerful on a cloud, like what NVIDIA have been empowering everybody to use a GPU to run very large models and can do very robust tasks. But we also need AI near to us, right? On your wearables, on your glasses, and now everywhere, even a sensor meaning camera, right? It's on the camera, on traffic cam. There are so many use cases, and now the technology can support that kind of technology. Back in the day, 2020, we're still early on time, but now we're ready, with all different innovation kind of spun everywhere. So vision-based model, vision-based language model is actually one of the good use cases, right? Leverage a sensor and transfer it into language models.
Okay. So, one last question.
Yeah, question about the mobility. So how do you guys think about the total cost, including infrastructure, including availability? AI can solve a lot of problems, but AI need to run from the power. We don't have infrastructure. The Santa Clara, 2 days ago, have a power outage, so we need infrastructure. So availability plus the cost, what is the total, the value to support mobility?
Well, the mobility is a very broad context, but in the case of AI-defined vehicle, I think you probably can speak a little bit more about how you're making more sufficient.
Yeah, I mean, first of all, it depends the perspective from which you are asking this question. So are you like a public agency deciding to make an investment on a given mobility technology, or are you a company that is interested in making a profit out of a technology? But let's assume broadly we want to understand the cost of mobility. That is complex. Of course, it goes from the cost of developing a mobility solution, deploying the mobility solution, but then reasoning also in terms of the positive, negative externalities with other segments of the society, plus induced effects. Like, for example, if you have a better autonomous cars and you have robotaxis, you might cause a mode shift from public transportation to autonomous taxis, which might negatively impact public ridership, which means that you will need the state will need to fill in something. So you see how the analysis becomes increasingly complex, which essentially means that, of course, there is no silver bullet to this question. It's also very much solution dependent. Back to SMC, the Sustainable Mobility Center, one of the things we're doing in the center is to foster interdisciplinary collaborations also with people from the business school to try to develop econometric models that allow us to think a bit more broadly what is the cost of a mobility solution across its life cycle is to better inform public debate.
Great.
So I can give you framing. I don't have like an exact solution.
Well, thank you very much. I mean, we've come to the end, but basing on my question to the panel, Arissa, I don't think you and I have much of a future in this AI world. So thank you very much.
I like EV too, though.